So was there a reason you drove me into the middle of the desert and left me there to rot, or...?
Project availability, sorry Ricky.
You're listening to The Cosmic Cast.
Hello everyone, and welcome to another episode of The Cosmic Cast. You're here with me. I put the hype in hypotenuse. Rick Bieber here. To my right, he puts the pi in Pythagoras theorem, John Burnett Fisher.
Hello.
And to my left, the insubordinate and churlish, Tom Harvey.
Yeah, hello.
And my gosh, we have a guest for you all today. I'm getting emotional. The lunar and Martian volcanologist, and she also does all her own choreography, Marissa Lo.
Hello.
Woo!
Hi.
Hello, Marissa. How are you doing?
I'm great, thank you. How are you, Ricky?
I'm good, thank you. Tom?
Yeah, I'm doing pretty good. How are you, John?
Pretty good, thanks, Ricky.
Good, thank you. So, Marissa, we always like to start off by just giving the audience a synopsis of who you are and what you do essentially currently. Okay. So, obviously, you're here at Manchester University.
Yep. So, I'm a first-year PhD student. I started here in October, and I'm working with the Volcanology Research Group and then the Isotope Geochemistry Group, looking at volcanoes on the moon.
Volcanoes on the moon, that's very cool.
Volcanoes on the moon, yeah. The main reaction that gets is people go, there are volcanoes on the moon? And I'm like, well, not active ones, but we see lots of ancient volcanic deposits.
How do they react when you say they're not active anymore?
Then they go, well, how do we know there were volcanoes on the moon?
Yeah.
They just think, oh, well, there's just craters up there and that's about it. Or it's made of cheese.
I get a similar thing in terms of when I say I look at rivers on Mars, and they're like, wait, there's rivers on Mars? And I go, oh, well, they're not there anymore. And they go, oh, well, how do you know that?
Yeah.
It's exactly the same.
And it feels very underwhelming.
Yeah,
they seem a bit, they're initially surprised, and then they're just like, oh.
Well, I generally find people are underwhelmed by me. So, yeah. So you're in an office with Tom and I, so we know you quite well. You started at the same time as Tom.
Yes.
And you've both been through a journey to get to where you are now. We've already talked to Tom about his, so yawn over that. But
I yawned, it's fine.
Okay.
But Marissa, what actually brought you to researching at Manchester University then?
So I suppose starting with my undergrad, I did geology at Durham University.
And before you went to uni, were you always like, I'm going to do geology? That's always what I wanted to do.
No, actually. So I suppose going back to A-level, I did geography and chemistry and physics, and I didn't really want to do physics because I thought I'd end up, I don't know, doing something in engineering or something like that my school was very heavy on that. Chemistry, I thought, I'll just end up working in a lab, and I didn't necessarily want to do that. Geography, I like the physical side of it, so I thought if you mixed all of those together, what would you get? So I ended up doing earth sciences, and I remember going to my first lecture at Durham, and I didn't know what a rock was. Like, none of my family are very sciencey. I'm the first person in my family to do science. Everyone else did English or didn't go to university. Okay. So yeah, I remember turning up at my first lecture and not knowing what a rock was, not knowing what a mineral was. So yeah, it was a bit of a gamble in hindsight. I was lucky that I did end up enjoying it because I didn't really know much about the course beforehand.
I think a lot of people don't know very much about the course.
Yeah.
I mean, aside from sort of knowing that it's a thing, but not that you necessarily want to do it or what it entails, I've spoken to a couple of people kind of on my undergrad and, you know, at meetings and things who literally didn't know geology and earth sciences was a thing. Yeah. One of my friends actually stumbled into the Earth Sciences Open Day by accident, right, and that's how he ended up doing it. So, I mean,
they're just giving them away.
Yeah. No, but it's true. I guess it comes from the fact that geology is not really taught in secondary schools, particularly.
Yeah. And it's very interdisciplinary as well. So
I think in my class at Durham, 1/3 did geology at A-level.
Okay. 1/3, that's still quite high.
That's pretty high.
Yeah.
I don't think there was that many people in my undergrad.
I think I knew one.
I think that's about right for my undergrad.
Yeah, so maybe it is the case that more schools are doing it now.
Possibly.
But yeah, my sixth form college didn't do geology at A-level.
Yeah. So it was literally of your own fruition that you thought, well, that's what I'm going to do then at university.
Yeah. I thought from my A-levels, what bits do I like from each of them? And then I thought earth sciences was the way to go, and luckily it paid off.
Yeah. So you turn up at university not knowing what a rock is, but somehow you go on to do a master's and then decide to do a PhD on it.
Yeah.
So what in that journey made you completely fall in love with it?
So let's see, when did I first realise that planetary geology was a thing? I think it was second year. I had a GIS, a geoinformatics module.
Which is basically looking at images from satellites and things like that.
Yeah,
on a
and
computer.
sort of analysing them. And I remember we did a practical about craters on the moon and making cross sections of them and looking at the near side of the moon versus the far side of the moon and how they differed. And then we got to do our own little project. So I remember doing one about sand dunes on Mars and their distribution across the surface of Mars. And then from that, I thought I wanted to go into sedimentary stuff. I think just because the lecturers I had were my favourite lecturers. You know, they were always very memorable lectures and they were very fun.
So in terms of looking at like rivers and how they deposit their sediment, or wind deposit sediment?
Yeah. So in fact, like, I probably was interested in the sort of stuff that you're doing now, Ricky. Sort of sedimentology on Mars. As the course went on, I found I took more volcanology and igneous related modules. And then when it came to deciding what to do for a master's, I applied to a few different ones. So some general geoscience ones, a GIS one.
And they were all in Durham?
No, they were at Edinburgh, UCL, and then the one I ended up doing was a volcanology master's at Lancaster.
Okay.
And it was there that I started thinking, I want to do something planetary related, but I'm not sure what I can do in the UK because there's not a massive community at sort of undergrad and postgrad level. There's no course for it. So I sort of looked who's publishing papers about this in the UK right now, and I came across the name of Lionel Wilson, who ended up being my supervisor at Lancaster. I did a project with him on lava flows on the surface of Mars.
Wow. But now you've moved on to looking at the moon then. Was there a reason you changed? I mean, was there a reason you betrayed the Martian community?
Sorry,
I'm not salty about her or anything, but is there a reason you stabbed us in the back?
He's not taking this personally, is he? It was mainly up to what projects were available at the time.
Yeah. So was there a reason you drove me into the middle of the desert and left me there to rot? Or
project availability, sorry, Ricky.
That's always the excuse.
It's as good a reason as any, to be honest.
Well, let's be honest, the volcanoes on the moon are much better than the ones on Mars.
Wow. Okay, fair enough.
I mean, you're slightly surrounded. Me and John are both moon-related people, so yeah. And
real lunatics, you could say.
I don't think you could say that.
Okay. I'm going to cut. And when I edit this, I'm going to cut that out. So it was the project essentially that drew you towards it.
Yes. I wanted to carry on doing planetary volcanism.
All right. So you and I, we're both 5-6 months into our projects.
We are. That's scary.
How are you finding it?
I think it's going okay. Most people tell me for the first year you're not supposed to know what you're doing. So I'm glad they say that, because some days I do, I think I know what's going on, and then someone asks me a question, or my supervisor says, have you done this? And suddenly
that sounds
I feel
right.
less confident.
So what are you sort of up to on a kind of day-to-day basis, and what is that leading towards in the kind of short term?
Okay, so I'll start with the broad overview.
Yeah, sorry, maybe go that way.
So the
Why?
Sorry, Tom. Sorry, did I just completely annihilate you? Sorry, Tom.
No, it's just I was trying to get there, and then
So I'll start with a broad overview of my project. So the big title is The Volatile History of the Moon. So I'll be trying to infer the volatile content of lunar magmas. The volatiles I'm looking at are carbon dioxide, carbon monoxide, water.
Yeah.
So in a volcanic eruption, at depth, so in your magma chamber, so deeper in the crust, because the pressures are higher, these are soluble in the magma, they're dissolved, but as you ascend, these exsolve, they come out of the magma and form bubbles. This is how more explosive eruptions occur. Once these bubbles are formed, it breaks up your magma, and this is how you get explosions of pieces of magma, which then form your smaller pieces of, say, ash.
So that's like explosive volcanism, is that?
Yes.
Yeah. Okay.
Yes.
So, for examples on Earth, what type of volcanoes are they the ones that are big coney volcanoes, or are they the shieldy volcanoes?
These are the more cone-like volcanoes.
Okay, cool.
So if you see pictures of, say, Mount Etna, which frequently has a nice ash column above it.
So that type of volcanism was occurring on the moon? Then?
Yes.
Wow.
Yes.
Okay. So the moon was quite violently volcanic at one stage.
So when you look at the moon in the night sky, you see these darker patches on it, and that represents the majority of volcanism on the moon, something called mare volcanism. So this is more basaltic material, so like what you see at Iceland and Hawaii. And those big round patches are massive sort of flood-like basaltic eruptions.
So are they filled in like large craters or something?
Yeah.
Okay,
So say if you get a pair of binoculars or you see a closer picture, you'll notice that the dark basaltic patches are quite circular. So when they erupted, they filled in lower areas, which at that time was craters, depressions.
But you're not interested in those though? You're interested in these cone-like features?
At the moment, I think my project will look more at the cones, but I may also look at the basaltic material as well. So the way that these volatiles relate to my project is that I'll be looking at images of lava flows, cones, domes, different volcanic features on the moon, and trying to infer the volatile content of the magma which created these features.
And you're going to be doing a lot of numerical modelling as well, is that right?
Yes, so one of the volcanologists in this department, Giuseppe Lespina, he developed a model for magma ascent on Earth. So this has been applied to lots of different volcanoes like Stromboli and Mount Merapi in Indonesia. And this looks at what points in your eruption column will your gases exsolve? At what point will it start to break up into the bubbles and pockets of magma? And then once it reaches the vent, what sorts of rates will it be coming out of the vent? This model calculates all these different things, and I'll be changing the input parameters for this and seeing what it would be like on the moon.
So really nailing down some of the specifics and some of the fine detail of what goes on in some of these eruptions.
Yeah, definitely. We've obviously got a much better idea of what the different parameters are like on Earth. So say what depth the magma is stored at, what the volatile content is of the terrestrial magmas, what the composition is. We obviously have a lot more samples for Earth than we do for the moon. I'm tweaking these parameters for a lunar scenario. There's going to be a few different assumptions I'll have to make, but hopefully it'll still produce something realistic.
So I guess something we always come back to is what we really need is more samples of these things then, don't we?
Yeah, definitely.
So ideally we'd send another robot up there to take a sample, or
people
even people.
Yeah.
John's volunteering.
I'm volunteering. I'd go. I'd go to the moon. I'm not sure about Mars. A bit too long a trip, perhaps.
I'm too tall to be an astronaut.
Are you really?
So I couldn't go.
What's the cut-off?
Ricky's height.
Ricky's height.
Yeah.
That's unfortunate.
It is. Well, yeah, I saw one guy who was taller
unfortunate.
than me apply, and they said no, he's fine. But for some reason, I wasn't allowed
It's just
to.
your exact height.
Yeah, you
That's
can be either
unacceptable.
side.
Yeah.
It's just to be my height.
Yeah.
So I guess that's a good question then. Would you ever, if you could, go to the moon? That's normally a question people always ask me about Mars.
Yeah, who would pass up that opportunity? Like, to get to see it in real life would be amazing.
Yeah. I think it's a lot less arduous because it's a round trip. It's like, what, a few weeks? Whereas, it's not like year-long travel to Mars and it's a whole affair.
Yeah, so
I
I
mean,
think
that does discount the risk of space travel, which is potentially quite
Well, that too,
significant.
yeah. You don't want to arrive
You know,
at Mars
it's-
and end up with cancer.
It's not. You don't just get a car.
what's important about the whole mechanisms behind volcanism, is it that you can learn about what the interior of the moon was like
Yes.
at some point in the past?
Yes. So I suppose the big science question behind my project is what was the original volatile content of the lunar magma? And going back to the moon's formation, most people have agreed that it was a giant impact formation.
Okay, so
I need to say more
something
about that.
hit the Earth when the Earth was forming very
Yeah.
early on in the solar system, and that material blew off, or blown off, even if you speak English, and it coalesced to form the moon.
Yes.
Right?
Yeah. So some sort of Mars-sized impactor hitting the still molten Earth, and sort of this ring of material coalescing to form the moon, and that's why we see lots of geochemical similarities between the Earth and the moon. So sort of understanding what this starting composition of the moon was sort of helps us understand that process.
It helps us understand what the Earth was potentially like then, back when it first formed.
Yeah.
Or at least the exterior of the Earth was
sort of
like,
the molten parts that were ejected out into space.
So you're going to do all this modelling, and you're going to
Yep.
be looking at various morphologies and stuff. Have you got plans to then link this to all the various direct measurements people have done over the past few years?
So to begin with, I'll be using their measurements for the volatile contents of these apatites and other different minerals, and putting that into the model and seeing what sort of eruption that predicts. So moving on from the magma ascent model, I'll probably also be using an ash dispersal model to see, based on all the numbers I pop in, what distance would these lava flows or these ash deposits, what distance would they cover? And obviously we can look at images and measure these distances. So it's a case of comparing those and seeing, do they match up? And if not, why not?
And I guess what's good about the moon is it hasn't got an atmosphere and has no wind.
Yeah.
So these things won't be eroded away by time, other than, I guess, by micrometeorites or something like that.
Yeah.
So tiny meteorites that hit the surface of the moon. But
Yeah, so most of the things, apart from micrometeorites churning up the surface a bit, and then slightly larger impact craters, most of the things I'm looking at, the features are still quite clear.
How old are they thought to be?
So the Mare material is between, say, 4 and 3 billion years old.
Wow, okay.
I'm not sure about the ashy and pyroclastic deposits.
Yeah, they're all about the same age. And that's the remarkable thing about the moon, is how old some of these lavas are. I mean, there's really not much material on Earth that's that old.
Yeah.
So it really is a unique window into the early solar system. How easy are the models to run? Is it quite complicated? Is it lines of code? Are they quite easy to tweak? Do they take a long time to run?
It's actually quite easy to tweak. So I started off by looking at the terrestrial examples, and they took seconds to run because all the parameters were there. And then I tried it for the different lunar gravity, different pressures, different temperatures, and so on. And I definitely noticed the speed it took was a bit longer. But I don't think that'll be too big of a problem in general over the project.
So you've really got potential to churn out a lot of data then.
Yeah,
That's
definitely, yeah. Especially because there's lots of different compositions we've measured from different lunar samples. So it's a case of I can just shove all that data in and it will keep producing lots of different data.
Yeah, that's going to be really interesting. I mean, particularly a lot of the apatite data, it's very questionable into what it really means. Apatites are some of the final things to crystallize in a basalt. So trying to back extract these concentrations are really difficult. And so having an independent way to try and test to see whether these calculations are correct, I think is going to be really valuable.
And obviously in a volcanic scenario, as I said, lots of your volatiles are going to degas. We don't know to what extent these apatites and different pyroclastic materials have degassed. Are we measuring the original volatile content, or are we measuring it after half of it's been lost to space?
This might not be a question that you can necessarily answer. It could be that you just enjoy doing what you enjoy. But what is it about the remote sensing, the modelling side of things that led you to choose applying to this project and doing this sort of work over some of the more sample handling intensive, more lab measurement based projects?
Okay. My master's project led quite nicely into this. That was a lot of modelling and calculations of how different lava flows would form on Mars. So yeah, I've just never really had much lab experience.
I get asked that same question because all I do is I look at images on a computer is how people describe it. And I don't work in a lab. And I just generally, for me, it's because there's so much that can go wrong if you work in a lab, but that is out of your hands as well. All I ever hear is about people saying, "Oh, my equipment isn't working."
Or they're waiting for time on a certain machine.
Exactly. So I guess there's that level of control when you know, if I get data, it's because I put the time in to get data, essentially. Whereas people who work in a lab, it can just be really bad luck that the machine's just not working, and then
Yeah.
6 months later they still haven't got anything. So
Yeah. Also, what I quite like is the amount of data. Obviously, we're looking at me and Ricky are looking at lots of satellite images.
yeah,
There's a wealth of data out there that
Yeah.
lots of which people haven't looked at.
Yeah.
So I know for lab-based things, you're normally working on small samples, or you only have a certain amount.
So what Marissa is saying is we do more work than you guys. that's what you were getting at, right?
You see right through me. You see right through me. Yeah.
Yes. Yes. One thing we've been asking a number of guests so far is there any bits of science that you find particularly exciting that's not within your particular field of lunar volcanism?
Well, I'm really into food, as in baking and cooking and eating food, obviously. And I'm very much I like to try different recipes and so on like that. So something, I remember an A-level chemistry practical, actually, we were making esters and different flavourings.
Oh, yes.
All the ones that smell like different fruits.
Yeah.
I remember really enjoying that. So yeah, I think something to do with food chemistry would be quite fun.
That's
Well, we should open up a tuck shop then.
Yeah. And also because I'm a non-meat eater, so I like seeing what different alternatives are out there and how they like recreate different textures of food using different ingredients. So yeah, sort of like food as a material science as well, I think would also be quite interesting.
So you're quite piqued by this this vegan burger that they've made. Supposedly
Definitely.
very similar. I saw a video about this a while ago, how it's made. It's absolutely fascinating.
You mean the
The one that's got on sale in supermarkets
one that's actually like
that bleeds slightly when you cook it.
That doesn't sound ominous in the slightest, does it?
So
Wait, I've seen a few like that where they use like beetroot in the middle to like keep it.
What
pink?
they've done is that they analyse the proteins that you get at different stages of cooking of a normal burger, and they try to synthesise those proteins out of genetically modified soya beans or something like that.
wow.
And so they've recreated this burger that does bleed slightly when it cooks because it produces hemoglobin, but in a slightly different way using these different proteins.
I've not seen that hardcore a burger.
I can't remember what it's called. There was a good video I watched about it on YouTube. I'll see if I
I've
can.
never heard you talk about anything so passionately before, John.
I just thought it was fascinating. But it's what you were saying, right? It's the use of chemistry to try and do something a bit different.
Yeah. So I think we should all thank Marissa for being
Indeed,
on.
you'll have to come back on when you got some results.
For sure.
I'm
That
you'll
sounds
be very
good. Yes,
interested to,
please.
learn what you've been up to.
And if anyone wants to know what Marissa looks like, she's actually in the intro video.
Indeed.
Oh, we did
Yeah.
doing some coding on her computer. So you should
yeah.
all watch that as well.
Yeah.
If you want-
In a
wanna be-
non-creepy
Yeah,
way.
if you want to be creepy.
Yeah, maybe.
She's at 53 seconds, whatever it is.
We'll put a timestamp in the description.